I'm Komal from UNC Chapel Hill. I'm part of their research department called RENCI. And today I think I forgot to turn on my camera, sorry. Um, and today I'm going to be talking about how I've been using AI in my day-to-day work, building research cyber infrastructure, what has worked for me and what hasn't, and the concrete patterns you can take away with you and try it in your projects and domains. I have landed on this after an year of doing this seriously, and the goal is not to convince you that AI is magic, but it is to show you that what a real working loop looks like and give you something to try maybe Monday morning. So to give you a quick context on who I am, and so you know where I'm coming from. I'm a software engineer working at RENCI, and I build infrastructure that the researchers use. I work across three NSF and DOE projects. Fabric, being one of them, is a nationwide programmable testbed. Pegasus AI is bringing AI to scientific workflow management systems. And Swarm is a more of a research-oriented project wherein we are reimagining workflow management systems with applying Swarm intelligence on them in a more distributed fashion. All of these will show up in the case studies. That is why I wanted to give you a brief heads up on which projects I work on. So why this matters for the research CI specifically? Our world has a unique shape. We typically are small teams, long-lived and build long-lived systems which run heterogeneous stacks and users who are themselves domain experts. So the pressure is real. The more ambitious science we support, the more facilities we have to integrate and and we have probably a flat or a shrinking headcount. So the AI tooling does not solve that on its own, but it changes the per engineer leverage we get in a way that's genuinely meaningful on how we plan our projects or what new projects we take on. So here's my thesis for this webinar in one line. Like AI is a force multiplier, not a replacement. It does not replace your judgment, your design taste, or your domain knowledge. They are still on you. What it does is it removes the friction from an idea to a working code. The 10 times claim is real, but it's uneven. For some tasks, it's transformative, and for others, it does nothing. So the skill and the thing I want you to take away from this webinar is learning when to lean on AI and when not to. So this slide talks about the various tools I have been using for my day-to-day work. I've been using mostly Cloud Code and Codex. I tend to lean on the terminal side, but I've also been using them in VS Code as well. But all of them, it's not running autonomously. So I am the one controlling what either of these agents do for me. So it's different than a Copilot style of working, which is basically providing you auto completion. When you're typing code, Copilot would auto complete what you were about to write. It helps you become faster, but agentic tools change what you can take on. And I have provided the link for the tools if you would like to try them. So this is the loop I run dozens of time a day. Like it's basically these 5 steps, but this will change the way you use AI agents. So I'm talking about them here. And then I'll show you some concrete examples of how I use this. So what I do is what I want from the AI assistant, I just write it in plain English. I include the constraints and the non-goals. And then I have these agents propose an approach to implement the goals I have been asking them. And I argue with it a bunch of times because some of the times the proposed plan it shares does not matches my vision. So I do not rush to the coding. I first discuss the design with Claude or Codex for that matter. Once I have a concrete design, that is where I ask it to go write the code or implement the plan we have agreed upon. One and even in the implementation phase, I don't ask it to do that in one shot. I would recursively ask it, implement only this bit of the plan we have come up with, maybe just phase one. So I can validate the code generated by AI, um, and see if it works, or if it's doing the thing I asked it to do, and is it going heading in the right direction or not. And and incrementally increase the complexity of the task to reach the eventual goal of the specification in the beginning. The key here is that you have to review. So you can't, if you asked AI to build a genomous code, you would not be able to do that. So in order to figure out how to review the code better, it's easier that if you make your test cycle simpler. So the key here is that you create a bunch of test code. So every time you're iterating over your plan or the code generated by your agents, you have a test suite. You can trigger that test suite and verify that nothing has been broken. So these two things are very key: the review and the test. I'm now going to show you a bunch of case studies how I have used the approach I just talked about in different projects I am part of, and first being Fabric. So let me talk about a little bit about, give you a context of what Fabric is. Fabric is a NSF funded programmable nationwide research testbed. This map shows you the research footprint of Fabric. It is spread across US, and we have a presence in Asia as well as in Europe. All the blue dots you see on this map are, we call them as sites. So these locations could be thought of as their own cloud, wherein we have compute, disk, RAM, along with the different kind of accelerators like GPU accelerators, network accelerators in the form of FPGAs or P4 switches. So when an experimenter wants or a researcher wants to run their experiment, they can request resources on Fabric. They could be a bunch of virtual machines connected to these accelerators and spread across the entire network. And if you see the blue lines here on this map are 100 gigabit links connecting these various sites on Fabric, and the orange lines show 1.4 terabit links. So you can run your experiments at scale on Fabric. And your experiments do not have to only live within Fabric. Fabric is connected to other test beds like Chameleon, Cloud Lab. We are also connected to public clouds like AWS, Google Cloud, Azure, using Internet 2's Internet Connect capabilities. So why Fabric is a good case study for AI? Fabric is like heavy infrastructure code, Python orchestration, slice topology, container VM provisioning, and measurement glue. Exactly the kind of repetitive schema, heavy work where an agentic coding assistant pays off, where a tiny team can punch well above its weight. So you must have heard about several other test beds, Cloud Lab, Chameleon, and there are plenty others. However, using each of these test beds requires you to learn about the Python SDK, for example, for that test bed, or the API for different test bed. But that is a barrier, and the users for our test beds are the domain scientists. So for them, learning a new API every time a new test bed they start using is a big bottleneck. So in order to address that bottleneck, we built a bunch of tools with Claude's help, and I will show those artifacts to you in a bit. This slide just shows them, like Loom AI is a browser-based GUI with an agentic assistant baked in, and these are packaged reproducible experiments we created, so you can run them again and again. We also created Fabric skills, which can be plugged in with Claude, so you can conversationally build your experiments. You don't have to learn our Python SDK. We also deployed several LLMs on Fabric, and you can use those LLMs with this agentic AI assistant, and you don't have to pay any money for it. And moreover, your entire data set or whatever you're conversing with these agents stays within Fabric, so it's much more secure. Like I was talking, why we built Loom AI. The barrier to learning every new test bed is hard. So we were wanted to try and reduce that barrier so domain scientists can focus on their domain science and not worry about how am I going to acquire resources. And we also wanted to make AI as a first class user, not just a chatbot wherein you can talk to it, but actually build experiments, deploy them, run them, capture results all through using AI. And keeping your data secure is another angle we looked at. That's why we have self-hosted LLMs that could be useful. So walking through the path from an idea to a running slice. Before I talk about slice, what are slices? In Fabric's terminology, slice is basically a bag of resources. So if you were running an experiment on Fabric and for example, you needed a bunch of compute nodes and some of the compute nodes needed to have GPUs, you would request a slice on Fabric. That is what I will be using this term a little bit more. So that's why I wanted to give you a heads up what slice means. And all these compute nodes, you would want to connect them through a different kind of networks. It could be a layer 2 or a layer 3. And if you're running at application layer, you don't care. You just want those VMs to talk to each other. So earlier it was we had capability for users to do that before AI before we built this tool, but it was people would have to use our Python API to build that experiment, and they would have to learn our API to do that. But with this Loom AI tool, what we have done is we have provided a graphical interface. So it reduces the barrier for them to use Fabric. It makes it very easy. And I'm going to show you in a couple of minutes how AI has also helped with that. So this is a small recording of how we have used AI to build this tool, and I'm going to show this. The Loom AI tool, which we built for Fabric using Claude's help. This is the tool called Loom AI. The view you see right now is the slices view on Fabric. Slice is a concept on Fabric, slice can be thought of as a bag of resources. So for every experiment you run, you would require some virtual machines. They could have accelerators like GPUs, and those virtual machines could be connected on network. So, for example, if I was to run Pegasus on Fabric, I would create a Pegasus cluster. Like in this case, I have requested a bunch of VMs. To be precise, I have 6 virtual machines. Some of them have GPUs associated with them, and some of them are just virtual machines and they don't have GPUs in them. For example, if I wanted to go and open a terminal on one of the virtual machines, I could just right click and open a terminal and then start typing in my commands. For example, if I were to look at the status of Condor, that's what I did. This was not possible even before. Before Loom AI, the only interface to use with Fabric was Jupyter Lab, and we had a very simplistic graphical interface as well on our portal. But oftentimes people would struggle with learning how to SSH into these VMs, transfer files into those VMs. With this tool, we have simplified all those things for our users. For example, if you go to the storage tab, you can drag drop files. You don't have to do SCP or write any command. You can check the resource availability across Fabric on different locations on Fabric, what is available. Oftentimes, the resources available on Fabric some of the resources are very popular. For example, GPUs are not available often if you were looking for them. So we added this calendar view wherein you can check for the availability, so you can request the resources in advance. We also added this map wherein you can see all the locations Fabric is available and what is the current state of that location. For example, all the sites in orange are like almost 76% utilized. Green is like they're relatively free, and red is they're like above 85%. So that's what you can do. Not only this, we also retained the old interface, Jupyter Lab. So if all the experiments you created before are still available and you can use them, you can still run them in the native way. In addition to that, we added a bunch of AI assistants into Fabric. One is something called Loom AI. Loom AI is a AI assistant we built. This assistant is trained with Fabric skills. It has information about Fabric, and it can talk to the LLMs we have hosted on Fabric. So all the data, everything you are conversing with it, stays within Fabric and is a secure solution to this. As you can see, I have interacted with it and done experimentation with it. The more powerful thing we did was we also enabled Claude Code in here. So you can run Claude in here and do experimentation. Let me show you how we can do that. Let me go back to this screen, and I am going to open Claude here. Uh, this is running as a Docker container, so I have Claude set up in here. I already logged. This is a paid subscription for Claude, so you will use your own subscription. I'm already logged in, so it doesn't ask me. But the first time you log in, it would ask you to prompt. And I'm going to now try and create a slice on Fabric that includes 3 nodes on 3 different sites, and all of them are connected with a network. Um, and the VMs should be running this OS. And imagine I'm just typing in this text to Claude, and Claude also has information about Fabric skills. So it knows how to create slices and everything. And it is going to do that for us. The slices tab, we can see it will start appearing at the bottom. You can see why a new slice was created, and it is right now in the configuring state. Once the slice is provisioned, it will change to stable okay, and I would be able to see the virtual machines in it. As you can see, I haven't done anything else other than just typing in the prompt. And I also want to highlight that while this is in progress, this entire tool was developed by just 2 people team, Paul Ruth and me. And we had a working prototype in 2 weeks ready. Building this on our own would have taken us a long time. And some of these features we had always wanted, but it was the process of this being up and running was accelerated by using Claude. As you can now see, the slice is up and running, and it's in stable okay state. Let me go and check. Yeah, all the nodes look good, but I'll wait for Claude to tell me if it's ready for me to use. As you can see now that the slices, Claude thinks the slice is up, it is fully configured, and it is providing me the summary of the slice, and I can see that all the virtual machines are up. I'm going to ask Claude. Can you please ensure if the ping works between these VMs? It run between. Sorry, I'm going to skip the rest of the video because in the interest of time, but you can go back to those slides and watch it again. But the idea I wanted to highlight was that you can build a very complex product using Claude, but you have what I have learned from all this is that having a spec first, designing with it first, and then talking about that design, and then going implementing in phases works the best. And it has reduced the time from an idea to a code like tremendously. How we got to Loom AI was we started with this just describes how we actually reached Loom AI. We started with exposing our API Swagger documentation to Claude and asked about it. And then we thought maybe building a MCP server was the right thing to do. And we did that. It worked well if you were trying to query things like finding out the resources I have or when are my resources expiring, can I extend their lifetime? Those kind of things, it worked well, but requesting resources or creating those resources, uh, it worked okay. But the things like if you wanted to run a command, it needs to know your SSH keys and all those details. So you had to share that information with Claude and the MCP server. So it wasn't a very secure solution. So that's when we started playing with this idea of creating Fabric skills. So using skills, you could build your own experiments. Those experiments could be a bunch of Python scripts or like legacy way of doing Fabric things, a bunch of notebooks which you could just run them because Claude created those notebooks for you and you didn't have to learn our SDK. That's all where it started. But then when we had all these things available at our disposal, we thought, why not build an integrated environment called Loom AI, which lets us do all those things and all the features we thought were missing from our existing portal because we thought Jupyter was the way to go. It wasn't that we couldn't do that, but it's just that it needed a tremendous amount of effort in building that tool. Next example I'm going to talk about is Pegasus AI. I would say that before I talk more about Pegasus, I am a new user of Pegasus. I didn't know about Pegasus. Like I knew about Pegasus, but I have been using it extensively for the last 6 months now, and mostly with help of AI. So what Pegasus is like if you have when you are trying to um, think of a problem and you're trying to analyze the results of that problem, or you want to run, you have an idea, a scientist has an idea, and typically they start with writing scripts and then they worry about when they're ready to move it to a scale. They think about how are we going to do that. Pegasus is a workflow management system that lets you translate your idea or scripts into code that can be deployed at scale on different kind of infrastructure. It could be access resources, near resources, or different test beds like Fabric or Chameleon for that matter. So without going into too much details about how Pegasus works, let me show you how I used AI to assist me in making my usage of Pegasus easier. Again, I will keep reinforcing this. Bringing AI to workflow management system, what I did was like I figured out how this spec-driven case study works well for me. And I think that it produces reproducible artifacts which can be used uh, by different users. Like I think that is something one key takeaway you should take away from here from this webinar that you can apply to your use cases as well. I again on similar lines like Fabric skills was able to build Pegasus skills, and where we are heading now is building a similar kind like a Loom AI kind of experience with Pegasus AI. So you have an integrated environment. You can design your workflows with AI, deploy them, debug them, and analyze your results. So again, reducing the learning curve for domain scientists to use Pegasus AI. So why Pegasus is a perfect match for AI? Again, similar things like Fabric. Uh, it's Pegasus workflow is basically Python code. It's very explicit about the kind of inputs it takes, kind of outputs it generates, its dependencies. It's very readable, and these agents understand code really well. So it was a perfect match to use AI for Pegasus workflows. These are the different kind of ways I have tried using AI to build different kind of workflows without knowing the nitty-gritty details of Pegasus. So I started with just doing a prompt, give it a prompt, give it an example of best practice workflow shared by Pegasus team, and asked it, I want to do this for my own domain. Can you help me create a workflow? And that worked pretty well. Then me and the other people from Pegasus team tried doing this with a napkin sketch, as in providing a picture and asking Claude and an example and asking Claude, could you please help us build a workflow for this? So these are different ways we have tried using AI to build workflows. Now let me show you a little bit more detail how that worked for us. What is the methodology behind all this is like you have different kinds of input, but the Pegasus AI engine stays the same. We built Claude code skills by pointing Claude through Pegasus documentation and the bunch of Pegasus examples, which as per the Pegasus team were the best examples to use for. And using those two things, we were able to generate skills for Claude, and those skills are I'm now able to use these skills to build workflows for different domains, for different kind of scenarios. And using these skills, I have built like 14 workflows in 15 days. If I, considering me as a new user of Pegasus, I don't think it was possible at all if I was learning, doing this by hand. So AI definitely helped here. This is one example wherein this is from, I think this is where I started from. I was prompting rather than doing a spec driven development. I gave it a prompt, I gave it an example. Can you reproduce this for a different kind of a domain? So I had one example. In this case, I created the soil moisture workflow, which tells like whether I should water my crops or not. And then once I had one workflow in the first prompt, I just asked it, but should I water my crops or not? And once I had that workflow running, I kept on doing incremental prompting to improve that workflow until I was satisfied with the results. And once I had the working workflow for soil moisture, I use that as an example for other domains, like in this case, air quality or determining the impact of earthquakes or determining whether the crops are healthy or not. And this is just, this shows how the soil moisture workflow worked. It'll analyze the data, analyze the moisture, train a model, and predict whether you need irrigation tomorrow or not. And then also visualize the results. On similar lines, we did this with a napkin sketch, as in scientists provided us a picture of their workflow they wanted to create. We fed this picture along with a pattern or an example workflow along with a prompt to both Claude and Codex, and were able to generate a workflow which was executable the first time itself. And then, of course, when you have a workflow like that, it's possible that it makes some mistakes and it's not always perfect, but you can again use AI to debug it and get into a running stage. This is where I want to highlight that this is the single biggest practical lesson I want to emphasize throughout this webinar is that spec first. Two prompts, you and can beat the continual prompting. Instead of doing repeated prompting, wherein you just tell Claude, build this for me, and then it creates the code, and then you keep on asking it to fix it. It's better to talk to Claude, or for that matter, Codex, to iterate over your design, ask it to create a design for you first, which you can review. And it's easier to review and criticize the design. And once your design is perfect, that is when you ask it to build the code. And don't ask it to build the code like the whole thing in one go. Ask it to build the code incrementally. So that way you can review the sections it builds. And it's easy for you to check, and because the domain knowledge is still with you, the design decisions are still with you. AI does not get that. This is also a video of how I use this to build a workflow for Pegasus. I'm going to play this video, but I might have to pause in between. Hi, I'm now going to be showing how you can design Pegasus workflow with Claude, focusing more on spec-driven development. I have built Pegasus skills, and all these skills are available on GitHub in this repository in the Pegasus organization. And there is a command in here which shows how you can install them. Let me bring back my VS Code editor, wherein I can show you how to do all this. Right now, I am on the VS Code editor. If you look on the left pane, I have a folder named Pegasus, which has a markdown file. If you see here, the markdown file has a bunch of data sets. And I want to build a workflow for federated learning and use Claude for that. And I also have Claude open up here. I want to install the Pegasus skills and make sure that those skills are available to Claude before I go ahead and build or design the workflow. If I do this, it says the marketplace is already added. I am seeing this error because I have already installed it. You would not see this error if you run this and you don't have this plugin already installed. So all the Pegasus skills are already installed in my Claude environment. Before I ask it to implement anything, I'm going to ask it, can you please build me a specification document which documents the design for a federated learning workflow, which is going to target two of these um, data sets. And I'm also providing Claude with two additional references. These references have not been covered by the Pegasus skills so far. So I want Claude to look at these two additional references. In this case, one of them is called an ensemble manager, and the second one is sub workflows. And I also wanted to use the existing skills it knows and focus on the data sets like TCIA and this NIH data sets. And let's see what it does. Claude has come back. It has read through the skills and the documentation I referred to, and it created a spec.md file, as you can see over here. And it describes the architecture, the data pipeline, and various things. And it also has documented some of the key design decisions it has made. So let me open the spec file. Let's do this here so I can close this. So this is where I as a human would review this spec file, which describes the design it is going to implement, and see if there are any changes needed in this design, or if it's doing something wrong, or does it align with my vision as or not. In this case, if you can see, it has figured out to use sub workflow for the federated learning. Sub workflow is a very complex feature of Pegasus. It's not something very easy. The fact that Claude was able to figure out that this is a good way to implement a federated learning workflow is really smart. And then again, it also has, it's also thinking of using Ensemble Manager to do multiple round iteration, which is again a very advanced feature of Pegasus. And just providing the documentation for it made Claude understand, and these skills it has to figure out that this is the right way to go is really remarkable. And now the idea is that you can go over this and review it and see if this makes sense for you. It has given some example codes. Sorry, um, I I think I clicked by mistake. But
Hi,
what I
I'm
want
now
to
going to
show
be
is what I
showing
want to
how you be
highlight
the
is
ideal approach. You just implement the phase.
what I want to point out here is that we have this video, and in the interest of time, I don't want to play the entire video. But if you can build a design with Claude first, review it, and once you like the design, let me fast forward it a little bit. I think I probably fast
Run for now.
So I like this plan, and that's when I'm going to ask it to implement the workflow. That I think that's what I did. Implement this plan based on the spec.md. Then it proposed an implementation plan, which is also not complete. You do the implementation in phases too, so you don't have a too big a chunk of code to review, because that is critical. Whatever code it generates, you just can't rely on it to always work, because then you are just generating, you're not designing stuff with Claude. You want it to be it still has to have your intelligence, because that is where this is useful. It's asking, should we be doing full ML logic? Let's say yes to that and submit these answers. It's going to take a little bit of time for it to create the workflow, and then it will come back. As you can see, it presented me with a plan for the phase one. And on the left, you can see the various phases which it presented before in the spec.md. And now it has the implementation plan for phase one, which is single site prototype. And I think I like the plan, and I'm going to accept and clear the context and let it do the thing.
So plot took some time and came back with the summary of the information about the workflow it created. So it has given information about the config file, what are the library modules it has created, some executable scripts, and Docker containers, how the workflow would be orchestrated, and how it also tried to validate the generated code because every uses Python code, so it's easy for it to validate. So it is the summary of all the things Claude did. And if you look here on the left pane, there is a directory named FL workflow, and it has all the generated code, binary files, containers, libraries, and output things. If you know,
Okay, I'm going to pause here, and now you can. This was just to give you an idea that how AI could be useful to generate code for you, but the design is still yours. You still own the design, and it is critical here that the key message I'm trying to show is that the spec-driven development, the design is still yours, and it is reproducible and a shareable artifact. Like before, we used to share. Code with other people, but I think the way this is going is we share these design documents or spec files with other people, so they can reproduce this work. So in this case, the spec.md generated as part of this example is a reproducible shared artifact. You can share it with someone else, and they can use it to build a federated learning workflow for their use case. Uh, I will show this more in the subsequent as ideas subsequent slides. So this is where we are going next. We have the skills. We have Claude trained on that with these skills. I've used these skills not only with Claude but also with Codex and with open source models. They Codex works pretty decent. Even open source models like Kimi, I've gotten decent results with that. You just have to have do more prompts with that. Claude is a little bit better. That is just my experience. I'm not saying that Claude is the best, but that is my experience. But where we are going is we are building a Pegasus AI, a Loom AI kind of experience for Pegasus, wherein we would have agents which would deploy using these skills, would be able to build workflows, deploy workflows, run them, debug them, all a very integrated environment. So the domain scientists don't have to worry about learning the Pegasus API, and they can start soon. I did record a video because I thought it could be useful if you were to try to create skills for your thing, for your domain, your project. All you have to do is point Claude to the documentation, a set of examples which are correct, which work, and prompt or talk to it to read those examples, share a plan with you about how the skills can be created. And once it shares a plan, look at it, you can review it. And again, if the plan looks good to you, you can ask it to create skills. Once the skills are created, your job is not done yet. You have to test them like we would test our software. You test them enough and you think they're good enough, you go ahead and share them with other people, like that GitHub repo I created. You can create something similar and other people would be able to use the skills for your project or domain. I am going to skip this so that I can cover the rest of the things that I have. This is where I wanted to show you an example of how somebody else created a spec and I was able to use it for our case. So let me show you an example. Just give me one second. There are off, this is more targeted for PIs or project managers. They're off every at the end of every year. I'm sure you have to submit the project reports or what is the impact your project has had to justify the funding you got, or if you want to highlight why you should get another round of funding. These are the kind of things you're looking for. For example, in this case, I'm showing the Fabric Research Impact Dashboard. This was created by Paul Ruth by using Claude. And this is his vision of how impactful Fabric has been. We do have all this information available in our database, which has APIs around it. And he was able to use Claude to extract that information using those APIs and create an executive summary of the research impact for Fabric. For example, how many users we have, how many institutions we have, um, and what kind of resources people are using, how many slices they are creating, and all that information. The key impact for Fabric, if you want to measure for any kind of test bed, is how many publications um, use Fabric for those their publications. And oftentimes people use test beds, but they don't come back and tell you that they use the test bed. So it's really hard for us to find that out. Paul was able to use Claude to build a tool that can extract this publication information based on users' profile because they're registered Fabric users. So we have their email addresses. Some of them also put their Google Scholar IDs and things like that. So he was able to use Claude to build a tool which uses Semantic Scholar, Scopus, and s- and Open Alex to extract the publications. And in fact, using that tool, we were able to figure out how many publications. We had a list of publications for Fabric, but we were able to use this tool and figure out how many additional publications we didn't know existed, and they would use Fabric. So that was a great way to use Claude to build a tool like that and figure out an impact dashboard. And all these pictures or the plots you see were generated by Claude, but we he Paul just told what needed to be generated, but all the code for this tool was written by Claude. And then this is not like a one-time thing. This is a tool Claude built, so we can run this tool every week to find out if there were new publications. Earlier, we were doing this manually, which is definitely not an easy way. So what I did was, out of this project came a specification.m markdown file and an interview markdown file. I used those two markdown files and plugged into Pegasus website. And Pegasus team was generous enough to share some of this information with me about. They collect some metrics about how many workflows have been running and what kind of jobs have been running. I don't directly have access to their API or data set, but I did have access to those dashboards, so I could download those pictures, pointed to Pegasus website, pointed to how many people or what people, who are the people who work for Pegasus, their team information, and use Claude with these existing specification and interview markdown files and interacted with it. And I asked it to create a similar kind of dashboard for Pegasus. This was just done in one afternoon because I was preparing for this webinar because I wanted to give you a realistic example of what it could do. So if it may not show all the information correctly because this was just a one-time build I did. I haven't verified everything, and I don't have access to all the data Pegasus has. So if you could see, like it talks about how these are a bunch of core papers Pegasus has and how many times those papers have been cited, how many workflows have executed, all those kinds of things. And it also creates a nice dashboard for what are the broader impacts of Pegasus and how it could help you. These could be some of the things you might be interested in if you were trying to report these to NSF. In fact, all this information, I just fed the same specification and and interview questions and was able to generate this dashboard. On similar lines, this is Pegasus and Fabric are projects wherein they offer services to the researchers. But what if you had a project which was just a research project? You are not offering any services. So I'm part of this Swarm project, wherein we are doing research and figuring out how we can reinvent these workflow management systems. I had access to the Swarm website. I had access to the people who work in Swarm and the GitHub organization. I just pointed Claude to those two things and answered the bunch of questions using the same spec file and the interview questions. And I answered some of the questions describing what kind of dashboards do I want to see, what kind of plots do I want to see, and it created the research impact for Swarm project. Um, it was I hadn't even thought about, like, having a team expertise H index would matter so much, but looking at it, it looks pretty cool that it can do that for you. It summarized y- on the first run. It didn't give me project goals and what are the key accomplishments, but yeah, I could iteratively ask, could you add that to how many site? So this was awesome, I think. And let me show you a little bit more. Like it went ahead, not only just gave me information about the publications we have had in this project, it also actually went ahead and classified the venues. I haven't validated the accuracy of those venues, as in if some venue is reported as A here, is it an A category? But this is just to show you that it can do those kinds of things as well. It's not just limited to doing coding kind of stuff, but it can do this kind of stuff as well, which could be very powerful for if you are presenting this to NSF or different funding agencies. Just to give you an idea of like team impact, it also created a graph of how many within this team, how many people from different institutions have collaborated. So these are some of the cool things it could do for you. Let me go back to my slides. Okay. Um, in some of the other things I have used Claude for is building the slide deck. In fact, this slide deck I used building Claude. Let me give you a quick example without taking too much time. I have this Claude plugin installed. I have this template for CI Compass slide deck. I downloaded, and then within this plugin, I gave it. I was trying to create a slide deck for a paper, which talked about how can be used for scientific workflows. So I have come up with this prompt, and then if I upload the paper as well, which has the content, and if I just hit enter, it will at least create a scaffold of these presentation for me. The entire information may not be correct, but you would get at least the slides for you. And okay. Um, Sorry, I did not realize that. Are you able to see it now? Okay, the idea being that if you use Claude this way, it can let you, it'll give you a scaffold of the presentation, and you as an author are still responsible for the content. And but it takes away all the tedious work of formatting or color coding based on your on the template, and it I find it very useful. Let me go back to the slides back so I can. Sorry, I have if I'm being rushed, but I know I only have like 13 more minutes left and a bunch of stuff to cover. Again, on similar lines, there is something called there's something called Claude Design. I am trying to see if I can. Are you able to see the slides? Yeah. Okay. There's something called Claude Design. Are you able, could someone please thumbs up if they can see the browser?
Yeah, we see. And when I need to start fresh cloud design, that's what we see in the slides.
Okay, yeah. Okay, cool. Thank you.
We
So
do
this
not
is,
see the browser, though.
I'm sorry?
We do not see a browser. We just see the PowerPoint slide.
Okay, I am sorry. Sorry, I'm struggling with this, but bear with me.
That's okay. You know, also come on. I don't. So we can also have you back for the second part also, but you
Okay,
know,
so maybe,
because I think people also have questions. So
okay.
maybe let's see if you know folks want to ask some questions about more details about the aspects that you already presented. It's been,
I am sorry, I had too much content and
no,
maybe I went
this is great.
overboard.
This is great. We'll invite you for part 2. This is great. Thanks.